filling in some space. So, how many moles of pentane, C5H12, must react to yield 2.4 moles of water? Okay. So when we go through and look at this, some things that might jump out. We're looking at moles. We're looking at pentane, moles, and water. Okay. So the big thing that I would note is that I'm switching from water to pentane. I've changed the substance. How can we change a substance? Conversions is too vague. But you're right. This is a conversion question. How would we be able to determine, or where do we find the information to allow us to convert substances? Mass has nothing to do with it. It has to come from a chemical equation. Okay. Conveniently, what did they give you? A chemical equation. Okay. So all I'm doing is marking what I think I'm going to need to use. I'm not necessarily going to deal with balancing it because maybe I don't need to do that. Okay. I could be wrong. Okay. But I just want to at least set that up.
Will you provide us with the chemical?
The final is the exact format. Yeah. Unless you are expected to know how to predict what the chemical equation was. Yeah. In this situation, the question itself doesn't give you enough context to know that you're running that chemical equation. Okay. So what do we want for an answer?
Moles of water.
Does everybody agree? We want moles of water?
How many moles of pentane?
Oh, sorry.
Pentane.
Moles of pentane.
We already know that.
We already know the water.
Sorry, thank you.
So okay. This is part of trying to write it out and see what's going on with it. What are you given? Moles of water. Are we given a numerical value associated with that moles of water?
2.4 moles.
2.40 moles.
Right.
Notice that I have a relatively large white space in there because I don't know how many conversions I'm going to have to go through and do. Okay. In the ideal world, in our initial statement, moles of water does not equal moles of pentane. This means I must run some kind of conversion. Okay. In that conversion, the ideal conversion, I'm going to put moles of water in the denominator because I want that unit to cancel. Okay. Ideally, I'd be able to convert moles of water into moles of pentane. Okay. Notice in this case I'm using the shorthand pent. So I figured that's less work than any other thing. Now that I have a unit system to look at, now I can ask the question, is that a numerical, or is there a numerical relationship that relates the moles of one substance to the moles of another substance?
It's in the chemical equation.
That is the system that comes out of a chemical equation. Right? So now I can go back to the chemical equation and say, okay, what are the numerical relationships that come out?
Well, we haven't balanced.
Okay. Remember, the numerical relationships must come from a balanced chemical equation. I can't just directly solve out of this by dropping in ones because I don't know what those numbers are necessarily yet, right? So I have to balance. How do I balance?
You have 12 H's on the left.
So we could go through and look at H's, but back to the rules that we talked about at the beginning of the semester. Carbon is probably the best bet to start with, but you don't have to start with there. That just happens to be the easiest one to start with. How many carbons do we have on the left?
5.
On the right?
1.
1. What needs to happen?
Times the...
I need to make it a 5 by making that a 5. Okay. I can now move to hydrogen. How many hydrogens on the left?
12.
How many hydrogens on the right?
2.
Is 2 and 12 the same?
No. So
What do I need to do?
Make it a 12.
5.
Well, yeah, you're making it a 12, but you have to multiply by 6 because there's 2 hydrogens in H2O. Right? That's what you were saying. Right? Now what? Now we move to oxygen. How many oxygens on the left?
2. Wait.
On the left?
2. 2.
What? Oh, I went to to the wrong one. 2.
There's 2. On the right, we have
16.
10 plus 6, which gets us our 16. How do I make 2 equal 16?
Times by 8. But unfortunately, that messes with your token. Yeah, it does. Yep.
Okay? Now what's our rule?
Get that. Recheck.
We now have to check everything. We've changed numbers. Anytime you change coefficients, you need to delete all of your work and you start again. Okay? If you're using a pencil, you could go through and erase. This is why I would say you should be doing this on the or on a blank piece of paper, your scratch paper, because then you can reset up your balancing process. Ideally, you do not look at your work because your work could be wrong. Okay? So you don't want to be evaluating your work at the same time. So go back through. Carbons on the left. 5 carbons on the right.
5.
Hydrogens on the right.
8. 12.
12.
Sorry.
There's the 2 and the 6. Hydrogens on the left.
12.
12. Oxygens on the left.
16.
16. Oxygens on the right. 10 plus 6 equals 16. Okay. We've now correctly balanced it. At this point, you've checked it. You've gone through. You didn't change any numbers. If you're short on time, you don't need to check it again. Okay? If you're having problems with balancing, what you should be doing is practicing these and checking it again at least twice more. Okay? By checking it, this removes the issue that potentially came up in our front of the classroom saying that, oh, now we have to rebalance one of the other elements. Okay? We don't have to rebalance one of the other elements. We know that because we went through and checked. Right? So, back to the question that was asked, I'm trying to find the numerical relationship between the moles of pentane and the moles of water. Okay? What number is associated with water in my balanced equation?
6.
What number is associated with the pentane in my balanced equation?
1. That's even 1.
Okay, this is where I have to do some interpretation. I wrote pent, that meant pentane, which meant C5H12. The number in front of that is
An arbitrary.
a what?
A 1.
A 1. Okay, so we have to be careful with where we place our work versus our solve. At this point, what unit would I have?
2.4 over.
What unit would I have?
Pentane.
The moles of pentane. What unit do I want for an answer?
Moles pentane.
Moles of pentane. That means the the numbers that I've established, or the units, are now all in their proper places. I can now punch it into the calculator. The 2.4 times 1 is 2.4. Okay. For the sake of those missing, we could also include it over 1, the beginning. 1 times 6 is 6. 2.4 over 6, that's now a division. I don't know how to do that in my head.
Less than
0.4 moles.
Okay.
Okay. Is this a sig fig question?
No.
Why is it not a sig fig question?
Because it doesn't give you other options.
All of our answer choices are to 3 sig figs. So I don't have to worry about sig figs. I can use whatever I want in my work. I can just write 0.4.
A and E are pretty close.
A and E are not different by sig figs. That's a numerical difference.
Oh.
Does that answer your question? Okay. So set up the process behind this. Okay. I'm not going to attempt to call you out, but because you asked the question. You're having problems with these. That's why you asked. Find 5 questions like it. Okay. Do those 5 questions. Come back and try this again and see if you can get the correct answer. Okay. Anytime you get a question wrong or need help with it, that's what you should be doing up to the final.
Why does it say yield in there?
just another term. So if we had said percent yield, that's going to be a different thing. Yield is just like making or producing. Yeah.
What did you get from that?
Yeah. What did you get from me? Yeah. Percent yield would very clearly say the percent as well.
Okay.
Can we do the next one? Is that
Okay.
what
Yeah, I don't want to do that. Let's make any extra statements. Yes. You got a 46, and Mary, you just added one too? You said
I said the next one.
the next one, 52. Okay, so we'll do 46. So 46. Sorry for the scrolling at home. Okay. We might panic and immediately, because it says moles, assume we're going to be running some kind of conversion. This is, again, pull out the scratch paper so you can do your work on the scratch paper so you don't have to worry about spacing on your exam. Okay. What are you being asked for? Moles of potassium nitrate. So that's what I need to solve for, moles potassium nitrate. Okay. If you don't know the formula to do an abbreviation, you can make up whatever abbreviation you want. In this question, conveniently enough, what else do they give you later in the question? The formula, potassium nitrate. Is there a question earlier in the exam that said, what is the charge on nitrate? And you're like, I have no idea what nitrate is. There's no way I could possibly figure this out because it's not telling me the formula. Read through the rest of the exam, see if maybe they gave you a question like this that tells you what that formula is. Okay? You've now used the exam to your advantage to get you over that hurdle of content that you missed. Make sense? Okay. So, moles of potassium nitrate. What is our given information? Given formula units, which is particularly irritating, and our substance of potassium nitrate. Did the substance change?
No.
No, it's still the same substance. So that's nice. I don't need a chemical equation. Okay? Conveniently, no chemical equation was given. Okay, so that could be a tip-off. What is the measurement unit? So the substance is potassium nitrate. The number is the 8.68. What is the measurement unit? Formula units. We talked about formula units. Yeah, I don't like using the term formula units. Instead, I use molecules. Right? Or as my notation, MLCS. Okay, so the given information, I have molecules of potassium nitrate. The numerics given with that, 8.6, helps if I'm looking at what I'm doing. 68 times 10 to the 20th. 20th molecules of potassium nitrate. I don't know if it's oh, and I can't move that stupid cursor now. Oh, I can. Let's get rid of that. Okay. Are MLCS the same thing as MOLS?
No.
No. Okay, so that means I have to do a conversion. In the ideal world, that conversion, MLCS would show up on the bottom. What would show up on the top? Moles of the potassium nitrate. Some of us are catching on being fully detailed within our units. Good. Is there a numerical relationship that relates the molecules to the moles? That is Avogadro's number. How do you know that number? You have to have that number memorized now. Okay, so there's content that you have to know. Okay, it is 6.022 times 10 to the 23rd molecules equal to 1 mole of molecules. All right. What unit would I have after running that calculation?
Moles.
Potassium.
Moles of potassium nitrate. Is that what I want for an answer?
Yep.
Yes. Now it's just a question of entering it into the calculator, making sure to enter it into the calculator carefully and correctly. Right. And a lot of people have been getting this one wrong, so I'm going to see if I can't approximate this. So we've got 8.68 over 6.022, 10 to the 20th over 10 to the 23rd. So 8 over 6, I'm 1 and change. Some numbers that I don't know because I don't have a calculator. Times 10 to the minus, whoa, hello. To the minus 3, which means my number, if I'm going to shift decimals, 1, 2, 3, I should have 2 zeros, 1, some numbers. Does that eliminate some answers?
There you go.
Oh my gosh, that puts it at answer D, which is exactly what the calculator spits out. And I would have that answer without a calculator. Okay, so being able to approximate is an important, useful skill. You don't have to rely on the calculator. It's not a bad idea to at least use the calculator to check your work. Does everybody see what I did with that calculation, the shorthand? Okay. Based on the mistakes I've seen, so I haven't gone through to check the wrong answers, but the submissions that have been sent to me have been picking between any one of those answer choices. The most common wrong answer choice being submitted is B. I'm suspicious, and this is going to be a setting in your calculator, I'm suspicious that what you've got your calculator set to do is spit out scientific notation. Okay, which is nice, because then you don't have to do any thought process, it just tells you scientific notation. The problem is that it'll spit out your answer as this 1.44 and then a bunch of other numbers. And then you're like, oh, well, the answer is just 1.44 because it shows up, except
It should be 10.
at the end of that string of numbers, it has E minus 3. That E is your power of 10. Right? So check the settings in your calculator. If that's happening to you, if you are one of those people that got B as the wrong answer, check that. Because I'm going to bet that's what's going on, is that it's adding that power of 10 at the end and you're missing it.
And if I thought mine was the same, but I did it in parentheses, one in parentheses, and I think the correct answer is D.
Yeah. So all I'm saying is that answer B, I think, is happening because people aren't reading the E to the minus 3 at the end. Right? They're ignoring that, and they're only reading the first 3 numbers. Okay? Read the entire thing the calculator spits out. Don't just start ignoring it because you're like, oh, sig figs, I'm going to ignore it. Okay? It does give you useful information at the end sometimes. Depends on the format your calculator's in. Does that work? Okay. Questions about what's shown? Are we good? Good. Okay. For those of you watching at home, we're going to spin some. What do we say, 52? Okay. You look at this question and you should be thinking,
Gas.
I can kind of accept gas. I would go broader first.
Conversion.
It's conversion. Why am I thinking conversion?
Aluminum to reactor.
This means scratch paper.
Yep.
Right. Pull out the scratch paper so that you aren't trying to cram it in there. So let's clear up some space again. Okay. We're asking for a mass of aluminum, so we have a measurement and a substance. This one's tricky. It's saying mass. How do you measure mass?
In grams.
Grams. How else do you measure mass?
Pounds.
Pounds, kilograms, centigrams, tons.
With a very specific.
How do you know what unit you should be using?
Look after the number.
What do you got, Kayla?
Well, all the answer choices use grams.
Unfortunately, that's the only way to be doing it. It's a crap question because the question should specify in the question what unit you want.
It does, it says
Okay.
1.00 grams.
Nope. That's not what you're being asked to solve for, though.
That's fair enough.
Okay, so you have to interpret from the answer choices. Okay, this is a badly written test question. That's what textbooks do. Okay, so be aware of that. Make sure that you're solving for the unit in the correct system that you're being asked for. If it's not explicitly written in the question, check your answer choices. Okay, so we're looking for what is the grams of aluminum that must react to release 1.0 grams of hydrogen gas, another substance. Okay. So we go back to what we want. What do we want? Grams of aluminum. What am I given? Stupid mouse.
Hydrogen gas.
Given grams, whoops. Grams of hydrogen gas. What do I need to be careful on here?
H2 to H.
This is H2. Okay, hydrogen gas is by definition diatomic, have no fear of ice cold beer. Okay, it's a diatomic element. We have to know that. The numerical relationship given with that was our 1.00 grams. Is grams of hydrogen the same thing as grams of aluminum?
No.
Nope. What does that mean I need to do?
Convert it
Conversion.
to moles.
Grams of H2. Ideally, I would go grams of aluminum. And for those of you freaking out, that doesn't exist. That's fine. This is what we need to be able to look at and say that is a crap conversion. Okay? You have to be able to acknowledge that. That is why you're making mistakes in longer conversion questions. Because you're just saying, well, I just need to multiply by something. No, you need to write down the units and decide that conversion isn't useful. Right? Does the conversion between grams of a substance to grams of another substance exist? No. Because of that, this conversion is invalid. I need to come up with converting something else. Okay? I have two options at this stage. I can either go through and add a conversion factor that brings in grams of aluminum. Okay? Most people do not do that. The reason being is that you're adding in yet another unit system or another unit to this that you're going to have to deal with canceling as you go through and solve. That becomes more difficult. Most people will go through and say, well, I'm going to focus on getting rid of grams of hydrogen. Now, what can I convert grams of hydrogen to?
Moles.
I can convert it to pretty much anything I want. What were you going to suggest, Kayla?
I was
You're just
going
gonna
to
say.
suggest moles.
Okay. This is where practice comes into play. Okay. As a general kind of rule of thumb of, oh crap, I don't know what to do, convert to moles. Because in moles, you now have the ability to go out, to branch out to a variety of other categories. Okay. Moles of what?
Oh, hydrogen. Yeah.
Of hydrogen. Okay. Why did I pick hydrogen? Well,
We have grams of hydrogen.
what happens if I picked aluminum?
We don't have conversion.
There's not a numerical conversion factor for that. That is why I don't pick moles of aluminum. I pick moles of
Hydrogen.
hydrogen. Where do I find that conversion factor?
Periodic table. In there.
That comes from the periodic table. Okay, the atomic mass reported on the periodic table, which is found where on our element?
Underneath it on the.
Underneath the element off of our table. For hydrogen, it's 1.0. You could use how many sig figs, whatever you want, but I'm just going to call it 1. Okay. Do we have just hydrogen?
No, we have two.
We have H2, so there's 2 hydrogens. That mass needs to become stupid stuff underneath this. times 2, and I get 2.02. What are the units associated with that? Grams per 1 mole. Okay, that's what the periodic table gives you. That that number is the number of grams for 1 mole. Okay? Having a hard time remembering that, that's okay. Write that information down on your periodic table as soon as you start the exam. Okay? You no longer have to remember it. Where does the 2 go?
With grams of H2.
With the grams of H2. What unit would I now have?
Moles of H2.
I would have moles of H2. Is moles of H2 the same as grams of aluminum? No. What do I have to do?
Converted to
I have to do a conversion. Again, ideally, moles of H2, grams of aluminum. Is that a valid numerical relationship? No.
However,
Okay. Stuff. However, I could convert to moles of
aluminum.
aluminum. Where is that relationship found?
So,
Where do I find the relationship or the ability to convert from one substance to another substance?
somewhere with the
From a balanced chemical equation. Because what does a chemical equation do? Convert reactants and make them products. That's the point of the chemical equation. Okay? So we can now go back up to our chemical equation and say, is that balanced? Well, I don't know. Let's start. Aluminum. How many aluminums on the left? 1. Aluminum's on the right. 1. So it must be balanced. I can stop.
Nope.
No. Okay, next element. According to the rules that we established earlier in the semester, we should go to chlorine before hydrogen because we should save hydrogen and oxygen for the very end. It's not going to matter here, but let's kind of stick with our rules. Let's go with the chlorine. How many chlorines on the left? 1 on the right? 3. What do we do?
Times by 3. Or times less by 3.
The left must be multiplied by 3. Hydrogen on the left.
3.
Hydrogen on the right.
2.
2. That should become a problem because we can't easily change one number. But I could change both numbers to equal the same thing. That same thing will be 6. So I'll change the 2 to a 6 by doing what?
Times the right by 3.
Okay. I'll change the 3 to a 6 by,
Times that by 2.
whoops,
10 to check your equation.
okay. And this is where I usually see people freak out. I go, well, but I changed a number, so now I've got to go back and change chlorine. Okay? Yes and no. Okay? Number 1, don't freak out and panic. You just went through an order the way we talked about. What's the next step?
Check.
Check. You go back to the very beginning and check everything from the very beginning. Don't be now, I'm going to spot check in random places. Okay? The problem with random checks is that they don't help you, particularly with a small data set. Okay? Aluminum's on the left. Aluminum's on the right.
1,
Chlorine's on the left.
6,
Chlorine's on the right.
3.
Is that balanced?
No.
What do you need to do?
Times by 2.
Times it by 2 to make it 6. I need to put a 2 here. Okay, again, oh my God, I changed. I don't care about aluminum. I did aluminum. I'm doing chlorine. Now I move on to hydrogen. Okay, finish the set. How many on hydrogen?
6.
6 and
6.
6. Okay, I changed a number.
Do it again.
So now I go back through and do it again. Aluminum's on the right.
1. Or right.
Right.
2.
2. Aluminum's on the left.
1.
Whoops. It is 1. It needs to become 2.
What was that?
Sorry. Okay, by changing that number, Chlorines on the left.
6.
Chlorines on the right. Hydrogens on the left. 6. Hydrogens on the right. 6. Did I change a number? Did aluminum go from 1 to 2? Yes. What do? I do it again. Isn't this a lot of work to go through? Yes, it's a lot of work to get the answer right. Shortcut and get it wrong. That's fine. Okay? It's not fine. I'm not happy with that. Don't shortcut. Okay? Do all the work. If you start to get into this, you're like, oh my God, this is 20 different conversion steps. I'm probably going to make a mistake. You probably will. Skip the question. Accept it as a loss. Move on. When you have time, go back. Okay? Aluminum's on the left. 2. Aluminum's on the right. 2. Chlorine's on the left. 6. Chlorine's on the right. Well, whatever. Hydrogen's on the left. Hydrogen's on the right. 6. Oh my God, I gave up, but I already had it balanced. Okay, I gave up just an instant too early. Oh well. Okay. Why did I do all the balancing? Back to the conversion. Okay. I need the ratio between moles of aluminum and moles of hydrogen.
Turns out 2 equals 3.
Why am I saying 2 in front of the moles of aluminum?
Because you have to...
That's the number from the balanced equation. What shows up in front of hydrogen? 3. Okay, what unit would I now have?
moles of aluminum.
Moles of aluminum. Is this the answer I wanted?
No.
No. So it was good that I skipped because I still wasn't done with the question. Moles, aluminum, what do I want? Grams of aluminum. When do I freaking want that? Hopefully by now, because this is ridiculous. Is that a valid conversion factor?
Yes.
Where's that valid conversion factor found?
Periodic table.
From the periodic table. And the periodic table tells me for aluminum, 13. No. Why no?
Because 13 is the amount of protons.
13 is the atomic number. It's the amount of protons. What am I looking for?
The mass.
The mass. I want the mass information.
Which still
So I go to
isn't about
aluminum, and it is
About 27.
26.98. I would probably have written 27 too. 26.98 what? Grams.
Well, 1 mole.
1 mole. What unit would I now have? Grams of aluminum. Okay. This is cool. I started with a random mass of hydrogen gas and was able to determine how much aluminum should have come out of that experiment or needed for that experiment. Okay? That's the power of the dimensional analysis and chemical equations and all of that. That's why we do that. Okay? Okay? Again, when you go through and solve these, what we're solving is the process. Look at the steps that we went through and did. Okay? I think I saw a camera phone come out. It's okay, you can take pictures. Looking at the answer doesn't help you. It's the process that we went through to solve. Why did we select the units that we did, and when did we place those numbers in? Okay? We can now enter it into the calculator, okay? Or we could go through, because we're lazy, and try and come up with some approximations.
About 54 on the top, and I'll be...
1 over 2 times 2 over 3 times roughly 30. The 2's cancel, the 3's cancel. I'm getting ballpark 10.
So rolling when the next sense is 13?
I only get one answer that comes close. C, 13. Anybody got a calculator?
Yeah.
Oh, haha. 8.90 is pretty close to 10. Sorry. So my approximation there got rid of 3 answers, but it left 2.
I got that.
So it is D.
Okay. So the answer is 8.91. Yeah, the answer is D.
Not the right.
Come on, I said ballpark 10. I just didn't read.
Unfortunately, you're at the wrong ballpark.
Okay. The ballpark eliminated 2 answers. I'm not in the wrong ballpark. The ballpark eliminated 3 answers. Okay. So, use your calculator. This is the point of the work. Are we good?
Yep.
Because Mary, that was your question. You're happy?
I'm
Wait. You're good? Okay. Anybody else have questions about that one? 67, about to do the magical spinning again. If I can get my mouse back.
Oh.
67. Right. I would make the argument that anytime you just see numbers, you should immediately pull out the scratch paper. Right? Because you're probably going to be doing a conversion. It may be, again, it may fit in that cram space. Try and fill up some space. I will have a ream of 500 pages of paper. Okay? Plenty of scratch paper. Okay? If you need more, just ask for it. I'll give you more. Okay? So what is the molarity of a sucrose solution that contains 10.0 grams of C12H22O11, 342.34 grams per mole, dissolved in 100 milliliters of solution?
Oh boy.
Right. This one, there is a big piece of content knowledge that you have to know. Right? You have to know what molarity is. Conveniently enough, someone told you that the instant you see molarity or capital M, you should be immediately writing moles over liters every time. Why?
Because that's molarity.
That's how you solve for molarity. Okay? So to solve this question, what do we need?
Molarity.
We need the moles and we need the liters. So now it's a question of establishing our conversion factor to go through and do this. Okay? Because you asked, do you want this in 2 steps or 1? 1.
2 steps.
Okay? I want moles of what? What's the substance that needs to go with this?
Sucrose solution.
The moles of the sucrose, which is a long enough word, and the C12 is a long enough word. I'm just going to write. Yeah, that's good enough. Suc
Moles of suc.
over what?
Liters of solution. Milliliters.
Liters of my solution. Am I given the moles of the sucrose?
No.
No. Am I given liters of solution?
No.
No. Which of those two do I want to work with first?
Moles.
Okay, you want to work with moles? Okay. How could I get moles of sucrose to come into my equation?
Grams times them.
Okay. I could get it from the grams using the periodic table. So moles of sucrose can be related to the grams of sucrose. Why did I write that up? Well, I want moles of sucrose in the numerator. That's why I wrote it that way. Okay, where do I find that relationship? I actually lied. They gave it to you.
Yeah, I think they gave it to you.
They actually gave you the moles right there. It's in the statement.
Because I-
That 342.34 is closest to what unit?
grams.
Grams, which means?
That's 1 mole over that amount.
Okay. I now have moles of sucrose exactly where I want it in the numerator. But is moles over grams the same thing as moles over liters? No. What is grams a measurement of? Mass. What is liters a measurement of? Volume. 2 different unit systems. I'm going to have to deal with them separately. Can I get rid of the grams of sucrose?
Sure.
So ideally, I'd put grams of sucrose in the numerator. Why?
So we get rid of it.
So the units would cancel. Okay? Because I know the grams is an entirely different system than liters, ideally what would be in the numerator? Or the other one? The denominator?
1.
1. Nothing. Okay? Because I know grams, mass, and volume don't overlap as a unit system, particularly with the content given here. Okay? I'm not going to try and convert in with liters. Okay? Am I given just the grams of sucrose?
Yes.
Oh. I'm given 10.0 grams of sucrose. Does that match with my choice to put a 1 in the denominator?
Yes.
Conveniently, that worked out perfectly. Okay? Because I'm given exactly 10.0 grams of sucrose with nothing in the denominator. Okay? So what happens with my unit system? Grams of sucrose cancel. I would have moles of sucrose. What do I want?
Moles over liters.
Moles over liters. Okay? Which means somehow or another, I need liters of solution to show up in the denominator. Am I given the liters of solution? I'm given milliliters. Okay? What is the numerics now that should go into that?
1 over 10 negative third.
Okay? So I'm hearing some 10 to the thirds, which is making me kind of happy. Not the 100, because the 100 is
Milliliters.
just milliliters. What have I written? Milliliters
Over liters.
per liters. Okay? The 100 has nothing to do with liters. Okay? What is the conversion factor between milli and liters? 10 to the minus 3 liters is 1 milliliter.
I gave you.
Okay? Yes, there's other ways to memorize that. That's entirely up to you. Okay?
And then you need
The
milliliters.
issue with this is that yes, I get liters of solution in my final answer, but milliliters of solution is now showing up in my final answer, and I don't want that. Okay? Which means that unit needs to disappear. It disappears by placing it in the denominator in the next step of my conversion. Okay? Ideally, what would show up on top? 1. Okay, so am I given in the question just the milliliters of solution?
Yes.
What am I told?
100.
100.0 milliliters of solution. What happens? The milliliters of solution cancel. Okay, and I can now go through and enter it into the calculator. I'm going to do a horrible job at approximating this one, but I can try and give it a shot. So 1 times 10 times 1 times 1 times 1, we got 10. 10 to the minus, I'm not going to worry about that one right now. 342.3, oh yeah, I'd have a hard time with this one. I would shift the 10 to the third up into the numerator to doing that. But then I'm kind of dead in the water,
It's
to be
this number.
honest. So I would enter it into the calculator. And unless I really, really didn't have a calculator, no, you didn't do the power of 10 shift. You just did the 10 divided by 342. We also have the power of 10.
Oh. I was just doing grams for some reason. Okay, so 10,
Somebody do it?
10
What'd you get? 0.0292. Isn't that what you got? Didn't look like you did the power of 10 shift.
0.292.
I got those. This should be closer, I think. Maybe. Maybe I'm doing my math wrong.
Oh,
Oh, but we didn't put
Sorry.
the 100.
sorry. I didn't divide by the 100, so that's why I screwed up that calculation. So make sure you track all the numbers. Everybody see that? Okay. 1 times 10 times 1 times 1 is 10. I did that right. And then I did 342.34. I dealt with that power of 10, but I didn't bring in the 100. Everybody see that? So my abbreviation calculation didn't work out so well. This is why it's nice to have a calculator. Okay. So, Kristen, you did go through and do that? You did it correctly with the 100 in it? You don't think so? Can someone
I
get...
got it. Same thing, just a little further down.
So we're getting a 292. Can I get a confirmation on that? Yeah. Thank you. And there's our answer. So you could have, and this is one of the reasons why general chemistry usually befuddled me. You could have awesome, fantastic work that shows everything, but in a multiple choice answer, you have to know the answer. So not only do you have to be able to show awesome work, But then you have to be able to enter it into the calculator right. And yours truly botched that pretty thoroughly. Okay. Or yours not truly. Falsely. Yours falsely. Didn't do that right either. Okay, so make sure you check your work. This can be something that if you've shown that work at the end of the exam, you can go back through and re-enter it. If you get the exact same answer, it's probably right, or your content knowledge is missing enough that you're not going to be able to fix it. Okay? If you get the wrong answer or get a different answer when you check your work, what should you do? Start everything over again. Okay? Yes, that sucks, but your work, one of your forms of work was wrong. And since you don't know which one, start the whole process again. Okay? Questions on that one? You don't like what? Yeah, the issue that made it complicated right now is that an idiot directing you couldn't read his own writing. Yeah. Okay, next question.
55.
Scrolling. So the question is for 55.
Selenium dioxide.
Okay. A big keyword, draw. If you got to draw, out comes the scratch paper. Okay? Because that means you're going to have to show some more work to kind of get through this. Okay? Draw the electron dot formula for selenium dioxide. Okay? You should be rock stars at this because you've memorized the rules that I told you to go through and follow every single time. The very first rule is exactly right, total the valence electrons. Selenium has 6. Oxygen has 6, but there's 2 oxygens. So I get 18 electrons. The next step is to pick our center atom, which is the least electronegative. That'll be the selenium. I'll scatter my oxygens around it. It doesn't really matter where I place them. I just want them around it. Okay. Yeah, never mind. Now I'll place my electrons. I will place my electrons on the most electronegative atom until I've achieved an octet. 1, 2, 3, 4, 5, 6, 7, 8. Okay. There are instructors that will go through and say, well, you should just place 6 because oxygen has 6 electrons. You don't have oxygen atom anymore. I'm sorry to those other chemistry instructors, they're wrong. You do not place 6 electrons around oxygen, you place 8. That's how it works. That's why we call it an octet rule. Okay. The next oxygen.
That sounded very curious.
It is, because I get irritated because it screws people up in OChem too. Okay. How many electrons have I put in?
8. Oh, 16.
16. I've put electrons on both oxygens. How many do I need to put in? 18. The oxygens already have all of their electrons, so I'll place 2 more electrons on the only atom left. That will be the selenium. I will place them where there are not currently electrons. Okay. Remember that when we're doing our Lewis structure, it's based off of ultimately cubes or squares, so place things off of faces of those squares. Anytime I have a pair of electrons between atoms, I'll turn that into a line to represent a bond. Okay. And now everybody's least favorite rule, I have to make sure every atom has an octet.
Which selenium doesn't.
The oxygens each have 8 electrons around them. The selenium only has 6.
So one
Okay.
combined.
So it needs more electrons. Okay. The way I will do that is by moving a pair of electrons. That's
It
only
really
getting
does
worse.
not like you today.
No, it's again the idiot behind the wheel. That would be me, in case you were curious. Between the atoms, and I've now done it. Okay. Do not move electrons from one atom to another, but I've now placed them between the atom. Okay, so we saw 2 hands, we'll do 1, 2.
Would you have to draw twice to get full credit?
Okay, so in a show your work,
You would?
would you need to draw another structure?
Yes.
Yes, because why did I take the electrons from the right oxygen? Couldn't I have taken them from the left? Yes. Okay. So in a show your work, I would have had to show 2 structures. Okay. That's the point of resonance.
So why wouldn't you do 2 double bonds? Because couldn't you connect the other oxygen as well and take the 2 off the bottom?
Because we'll
So if I remove those 2
Yeah.
and then do that, how many electrons are now in the structure?
16.
Oh, okay.
Does that make sense?
Yeah.
Okay. So when we go through and do this, the whole point of going through very methodically and stepwise is that it covers all your bases. And it's not just, well, I'm going to place these here, or I'm going to place these here. Okay? And ultimately, that's what ends up happening, is students go through and say, well, I saw a tutor, and they drew carbon dioxide like this. Okay? They just said carbon dioxide was this structure. And I was like, oh, okay, so you drew the center atom, and then you drew the bonds, and then you drew the oxygens, and you drew the dots. Okay? No, they knew what the answer was and drew the answer from memory. None of how I just wrote CO2 follows any method other than I knew the answer. Right? And that's where it becomes very tricky for students, is you watch someone draw the answer and go, oh, that was the steps they went through and did. No, they knew the answer. Okay? So you have to be careful to follow a process, a sequence of steps. Okay? We've now achieved the proper Lewis structure for selenium dioxide because every atom has an octet. We can now go through and answer the question. It's asking about the number of single and double bonds.
So the answer is
I have 1 single bond, and I have,
1 double.
1 double bond.
No, we have 2 single bonds.
And the answer becomes, you're probably more correct by saying that, A. 1 single bond and 1 double bond. Okay? Follow the steps I've outlined. It will always get you there. Okay? Be careful watching other methods for Lewis structure. That's all I can say, is just be careful. Okay? Does that work for you? Okay. Any other questions about that? Okay? Ooh. Lots of scrolling, so I apologize. Said 33? Okay. This is one you could probably get away with just squeezing in. Okay. But I write big, so. What is the chemical formula for the ternary compound composed of cobalt plus 3, or sorry, CO plus 3 and SO4 minus 2 ions? Okay. So what they are asking for is if I take cobalt and I partner that with sulfate, what number shows up for the amount of cobalt? What number shows up for the amount of sulfate? Why did I put parentheses around the sulfate?
Because it's an ion and the number needs to show that it's for the whole ion.
The Y needs to apply to everything within that parentheses. I want to make sure it doesn't become 4Y. Okay, that 4 is part of the name that makes it sulfate. Okay, to go through and process this, this comes back to our rules for how we deal with nomenclature and how we balance this out. Okay, the rule that we talked about in class, the number of atom A plus the charge on A plus the number on B plus the charge on B must equal 0. Okay? Officially, what it equals is the overall charge. Most cases that you'll be dealing with, that overall charge will be 0. So when we're being asked for the compound, we're asked for a 0 overall charge. Okay? If we go through to make in some substitutions, what is the number of atoms of A? Well, A I'm going to call cobalt. What is the number of atoms for cobalt?
1.
X. I don't know what it is. I wrote X there for a reason. I literally have no idea. What is the charge on cobalt?
+3.
What is the number of atoms for B?
Why?
Y. That could have been a funny exchange. We'll just let that go. What is the charge on B? -2. This must equal 0. So 3x minus 2y equals 0. Right? So 2y and 3x must somehow balance out. What is the lowest common multiple between 2 and 3? 6. So how can I make this first number a 6?
Times by 2.
Make x equal to 2. So I would get 6 minus 2y equals 0.
No.
6 equals 2y. 3 equals y. Go back up into my initial solve. I'm saying this should be cobalt 2, sulfate 3.
Now check it.
Okay. And I could go through and check it, okay, using the same process and just reverse that process backwards. Okay. There are other methods. The textbook uses something called the crossover method, which removes your understanding. Okay. It might allow you to solve this one question, but then screws you over for other questions. So that's why I don't use the crossover method. But if you want a shortcut for that, check the textbook for the crossover. Okay. Does that make sense? Answer your questions? Other questions about this one? Okay, next. Really? Everybody's like, I got, okay. Oh, wait, come on. 9, more scrolling. I see numbers, I'd pull out the scratch paper. This is probably one I didn't need to pull out the scratch paper on, but I do it anyway. Osmium is the most dense element, 22.5 grams per centimeter cubed. What is the mass of a 10.0 centimeter cubed of the metal? What am I solving for?
Mass.
Mass. What units of mass?
Grams.
How do I know it's grams?
It's in the answer.
Unfortunately, I have to go back and look at the answer. This is, again, another poorly written question. Right? So what I'm solving for is grams. Grams of what?
Osmium.
Of osmium. Okay? I have to make the assumption that the actual question, metal, is referencing osmium. If it didn't, this would be an impossible question to answer. So we are making an assumption there. Okay? What am I given? I'm given 10.0 centimeters cubed and 22.5 grams per centimeter cubed. Which of those two do I want to use first? Why do you want to use 22.5 first?
That's already free.
That already has a gram value in it. That's what I want for an answer. Okay? So I would probably use that first. I want grams. This was per centimeter cubed. The number that goes with the grams, 22.5. The number that goes with centimeters cubed, 1, so it doesn't change the meaning of the 22.5. Okay. Officially, we do have the substance on there. Okay, but the substance didn't change, so we could ignore it. Okay. Is grams over centimeters cubed the same thing as grams?
No.
What needs to happen? I need to cancel it out by placing centimeters cubed of osmium in the numerator in the next step. That's the ideal circumstance, so that it directly cancels. Am I given centimeters cubed of osmium in the question?
Yes.
Oh,
10.0.
I'm given 10.0. What happens?
Over 1.
Officially over 1, yes. The centimeters cubed of osmium cancel. I'd be left with grams of osmium, and there would be my answer. I just multiply the two numbers. Okay? And just kind of for the record, From the person that asked the question is getting kind of like, oh God, duh, that was really simple. Yes, because we're following this process. The process will determine the answer. You don't need to stress about, oh my God, what is density? What are these things?
It's the cubes.
It's putting those things down. And yeah, you may have seen this centimeters cubed thing and freaked out and go, oh my God, I remember Mike asked some jerk-off question about being tricked with centimeters cubed. Worry about that if you have to. It says centimeters cubed. Is that what you're given? Yeah. I don't need to worry about some weird cubing thing because that information was given directly to me in the question. Okay? Make sense? Questions? Is that a question?
Yes. We already did this one, so I apologize to everyone. It was, can you go through how we got to the answer B on 23? Sorry. Just use the periodic table, just real quick. I have the right answer, but just walk through that.
Electron configuration, nickel. Okay, so electron configuration is looking at the number of electrons for our nickel atom. So one of the things that we'll do is use the periodic table to our advantage. Okay, to initiate, we have to know the symbol for nickel. N, right? Ni. Okay. If you do not know your element symbols, you will have a bad time on the exam. Okay, so I need to look for the element of nickel on the periodic table. So let's close out of this for a second. Come on, art monkey. Okay, where is Ni on the periodic table?
Middle-ish.
Middle-ish. By the angry guy. Right, there's our nickel. Okay. Remember what we talked about is that we had the S block on the first two, D block, P block, F block. So we're located in the heart of the D block. The D block starts, that first row is at what energy level? The third energy level. Okay, so we're 3D. Which column are we? 1, 2, 3, 4, 5, 6, 7. Thank you for those of you who can count faster than I can. Thanks for rubbing it in. 8. The last one needs to be 3D8 to explain the last electron for nickel. Okay? That's where I would start first. Okay? So with that, I would then go back to the exam. And because I had the periodic table directly in front of me, where I didn't have to flip or move to it, I could then look back and forth at these things without having to oscillate back and forth on a computer. I would look for the last electron configuration to be 3D8. So 4p, 3d, 4d, 3p. That says 3d8. Okay. What I could go through and do is take a second glance through and make sure 3D8 didn't show up somewhere else in there. So in that first one, no. The third one, nope. Right? Yeah, they didn't make this question very hard at all, did they?
No.
No. Okay. That's where I would start. Okay? After that, you can backtrack through and make sure that everything else before that filled and is in the proper order. They tend to not ask order questions for electron configurations in 130. 151, yep, it's a lot more complicated. Okay. We are, what do you got?
No, so basically 24 is just the opposite. You just take
24 is the opposite now, is flip it and go the other direction. Okay. Again, I would start at the end because that is the most identifying piece of information. 3D6. So 6th column, first row of my third energy level, or of my D block. 1, 2, 3, 4. I'm going to say that was iron. I didn't do a very good job counting that for my point. That ended in iron. Oh, well. There it is. And I'd be done. Okay?
I did.
And with that, we're at the end of class. If you have questions,